In order to secure a network, one must understand the devices and technologies that we use every day. In this video, we will define the basic network components, review the OSI network communication model, and then look at the roles of routers, switches, and firewalls in our networks. There are several components that make up a network. Device: any hardware that participates in network communication, such as computers, servers, printers, tablets, and smartphones. Protocol: a definition of rules and conventions that govern communication between network devices. Think of a protocol as a language. Just as words have meanings, and those meanings govern how we communicate verbally, protocols provide rules for communication and define the structure within which that communication takes place. Media: carries the signals between devices on the network. There are two basic types of media: bound media, which is physical in nature, i.e., a wired network such as Ethernet, and unbound media, which is not physical, i.e., wireless, such as 802.11g networking. Network adapter: the hardware which takes a signal off of the media and presents it to the network device. In the video on Network-Based Threats Part 1, we were introduced to the OSI model. The purpose of this model is to illustrate the process of network communication. The various processes necessary for network communication have been broken down and divided into 7 distinct layers. Each layer is responsible for taking the information from the layer above it or below it, performing its specific functions, and then passing the data on to the next layer. The 7 layers of the OSI model are application, presentation, session, transport, network, data link, and physical. The layers are often designated by layer number. They number from the bottom up, physical being L1, data link being L2, and so on. Each layer is responsible for a discrete portion of the communication process. The application layer, L7, is the layer that takes the information from the application and begins its transmission process, and conversely ends the process on the receiving machine. The application layer identifies the communication partner, verifies resource availability, and synchronizes communication. Examples of application layer protocols would be HTTP, FTP, and SMTP. The presentation layer, L6, translates the data from the networking format to the application format. The presentation layer is responsible for compression-decompression and encryption-decryption of the data. The session layer, L5, opens, closes, and manages the sessions between the application processes of the two computers in the session. The transport layer, L4, provides seamless transfer of data to the upper layers of the model, providing end-to-end error recovery and flow control. TCP and UDP are layer 4 protocols. The network layer, L3, provides switching, routing, and logical addressing of the packets. IP is a network layer protocol. The data link layer, L2, is responsible for encoding and decoding the data into a flow of bits. The data link layer is made up of 2 sublayers, the MAC, Media Access Control, and LLC, Logical Link Control. These sublayers deal with the computer's physical address and how it negotiates access to the media. The physical layer, L1, takes the bit stream from L2 and places it on the media. Standards for cabling and communication are established at this layer. Ethernet is an L1 standard. In layered communication, such as presented in the OSI model, the layers on the 2 machines never directly communicate. The information appended to the packet by L3 on the sending machine is stripped off and processed by L3 on the receiving machine. Much in the same way that you might send a letter through the mail, you never directly communicate with the recipient. You simply hand a letter to the postman, who takes it to the post office, who sends it to the next post office, that gives it to the recipient's postman, who gives it to the recipient. As long as each layer performs their function, you will have a successfully delivered letter. This is exactly how network communication works through the OSI model. Network devices provide differing levels of connectivity and function at particular layers of the OSI model. Whether for large or small, for commercial or home use, their functions are consistent within each device type. A hub or repeater is a layer 1 device. There is no intelligence applied against the packet. It is simply repeated, passed on to every port except the one it came in on. Hubs have mostly obsolesced as network speeds have increased and the cost of other faster devices have come down. A switch is a layer 2 device. When a packet arrives at the switch, its source MAC address is recorded in the switch's CAM table, Content Addressable Memory. The CAM table simply records the MAC address of the computer plugged into each port. So when the switch receives a unicast one-to-one communication, it only sends that traffic to the port that the target of the communication is plugged into. When the switch receives a broadcast one-to-many communication, it will send the traffic to every port except the one it came in on. A router is a layer 3 device. A router moves traffic from one logical subnet to a different logical subnet. So it gives us greater scalability in that we communicate beyond our own network. But the networks still must use the same protocol. Routers will route traffic through the shortest, fastest path to a destination, do not pass broadcast traffic, and can be configured to filter network traffic as well. A proxy server is a device that isolates your internal networks from the internet. It does this by downloading and caching files on behalf of your client machines. A proxy intercepts the request coming from your internal network, then generates a new request to the web server for the file requested. When the web server responds, the proxy will sometimes cache the response depending upon the nature of the data, and then forward the response to the internal client that made the original request. A firewall is software or hardware that works to block unwanted network traffic. Firewalls can exist at multiple locations. There are host-based firewalls, where the firewall is installed on a single client computer. Network-based, dedicated hardware and software that provides a layer of protection at the network's perimeter. Application-based firewalls. This firewall looks for specific input that may be malicious and protects your web server, database server, etc. from receiving the suspicious traffic. A firewall will examine traffic at layer 4. It is concerned with two protocols, TCP and UDP. The firewall is usually configured using pessimistic filtering. This means that all 65,536 TCP ports and all 65,536 UDP ports are blocked. Then the traffic that is desired is permitted. This implicit deny ensures that only traffic that is explicitly allowed will be passed into your network. A typical placement of a firewall would be between the internet and your DMZ, or screen subnet, and then another between your DMZ and production networks. This provides a greater level of security than a single firewall, in that the traffic must be explicitly allowed to pass from the internet to the DMZ on one firewall, and then the traffic that made it through the first firewall must be explicitly allowed to pass from the DMZ to the production network. In this video, we defined basic network components, reviewed the OSI network communication model, and then looked at the roles of routers, switches, and firewalls in our networks. In our next video, we will continue our look at network security with Network Devices Part 2.